Alright guys, today we're going to be talking about how to determine if a rational function has a horizontal asymptote. So in the previous video we went over how you can determine if a rational function will have a vertical asymptote and where that will be occurring. Here we're going to be talking about horizontal asymptotes. So it's a little bit different than the vertical asymptotes, how you go about finding them, but it's pretty simple. You just have to follow these rules. So this f of x equals p of x over q of x, this is just, our rational function. And we have these following three rules here that we need to follow. So the first one says if degree of p is greater than degree of q, there's no horizontal asymptote. So remember, when we're talking about degree, we're talking about the highest exponent value between the terms. Okay, and we'll go over that. We'll do a couple of examples here. All right, second we have if degree of p is less than the degree of q, horizontal asymptote at y equals 0. Okay? And the last possibility is if degree of p is equal to the degree of q, horizontal asymptote is the line. All right, and we'll go over what that means. So let's do a couple of examples here. So if I give you the following, let's look at this. If I have, let's do this in another color, x squared minus 3x minus 4 all over x, and I want you to tell me, where is the horizontal asymptote occurring here? Well, you're going to your degree here. So if I go to the numerator, what is going to be my degree? Well, it's going to be this x squared value, right? If I go to the denominator, what's going to be my degree? Well, it's just going to be x, right? X to the first power. So I can see that p, right, which I have on top, this is p, this is q. So p is greater than the degree of q. Okay, right? P is greater than q here. As a result, there's no horizontal asymptote. Before we even graph this, we already know that this has no horizontal asymptote. All right, so there's no horizontal asymptote there. Okay, let's try another example. So what if I had x minus 2 all over x squared minus 1? Okay, so my degree on the top is going to be this right here, right? This x to the first power. My degree on the bottom is going to be x squared. Right? So in other words, my p is going to be x, my q is going to be x squared. Okay? Again, we're looking for the degree here, so the highest exponential value. All right. Well, looking at this, I can see that q is going to be greater than p here. So if that occurs, it says if degree of p is less than, right, it's less than degree of q, horizontal asymptote at y equals 0. So that tells me when I graph this, I'm going to have a horizontal asymptote at y equals 0. So I'll have a horizontal dashed line at y equals 0. So that is where the horizontal asymptote is occurring in this problem. All right, let's look at one more. So if I have 4x minus 12, and I have x minus 1. Okay, again, determine what your p is going to be, determine what your q is going to be, and again, that's going to be the highest exponential value. So if we look here, my p is going to be, right, this 4x, right? Q here is going to be x, right? Well, if you look at them, they're both going to have the same degree here, right? Because remember, this is to the first power and this is to the first power. So they both have the same degree. If that's the case, it says if degree of p is equal to degree of q, horizontal asymptote is the line. So what does that mean? Okay, that means, well, my coefficient in front of this term is going to be 4, right? So it's going to be 4. My coefficient in front of this term is going to be 1, right? It's not written, but we know it's there. And they both have the same degree. We said that if they have the same degree, horizontal asymptote is the line. So that all that means here is you just do 4 divided by 1, which is going to be 4. That tells me where my horizontal asymptote is at y equals 4. So at y equals 4, we'll have that horizontal dashed line. All right? And these are the three rules you just have to remember, so you may want to write them down when determining if a rational function has a horizontal asymptote. All right, okay, let's try some problems putting this to use now.